Good morning, and today we will be continuing with exact values and specifically looking at how to find exact values of values larger than 90. So we have our table of values as we have already worked out previously, and they all come from using the exact value triangle. So remember to learn these triangles. Okay, and we're going to be seeing how to use exact values to solve trigonometrical problems. Right, so we're going to be looking specifically at finding exact values of angles larger than 90. Remember, we know this from National 5. Okay. Remember, it goes in an anti-clockwise direction. From there to there is 90. Then that would be 180, 270, and that would take you back to your 360. Now, we split the graph into 4 parts, and we show it on this table. And each of the parts we call quadrants. So this between 0 and 90 is the first quadrant. Second quadrant, 90 to 180. Third quadrant, 180 to 270. Fourth quadrant, 270, back to 360 again. In the first quadrant, all of the graphs, the sine, the cos and the tan, are all above the x-axis. They're all positive. All the y values are positive. In the second quadrant, it's only the sine graph that's positive. The cos and the tan are actually below the x-axis between 90 and 180. So it's only the sine graph that's above, and that's the only one that's positive. It's only the tan graph that's positive between 180 and 270, and it's only the cos graph that's positive between 270 and 360. And we remember that little table, we use that little table with all sine, tan, cos. All sine, tan, cos. Okay, some people call it the cast diagram because round that way it spells out the word cast. Just be careful if you use this because you're actually starting with the letter in quadrant 4. Okay, I just remember it's all sine, tan, cos. I'm going to show you how to do this with an example, but this will remind you and it will make more sense when you see the example in working. So in order to find an exact value, first rewrite the angle in terms of its associated acute angle, i.e. the angle from the line to the horizontal axis. And remember how you can find its associated acute angle. If that's the angle there, A, which is in the first quadrant, that's the angle that you get when you put things into the calculator. That's the angle that you'll get when you use your exact value triangles, okay? The second quadrant would come from doing 180 minus that angle. The 180 line is this line here. That's why we're going to be looking at the angle that the line of the actual angle makes with the horizontal line, because this line is 180. So 180 minus the angle will give us our angle that we're dealing with. 180 plus in that quadrant. And this one is 360 minus, because right round to there is back to 360 again. So 360 minus the angle will give us our angle that we're working with. This is the first quadrant, as you can see from the sine graph. Second quadrant, third quadrant, and the fourth quadrant in there. And that's representing the quadrants that you actually see on the graph. Okay, let's look at an example. What is the exact value of cos of 300? So you might think, I can only do exact values of 30, 45, 60, or maybe zeros and 360s and 90s from knowing what the graph looks like. But how can I do cos of 300? Just remember that we can relate it back to the acute angle, okay? So the cos of 300, let's try and mark in roughly where 300 would be on this diagram. Now remember, we go in an anti-clockwise direction. So from there to there would be 90. That would be 180, 270, 300 would be somewhere in here. So that big angle there would represent the 300. So we'll just draw that here. The yellow line shows the angle. That's an approximation for 300. Okay. So look at the quadrant that we've drawn this line in. It's in the cos quadrant. We've got the line in the cos quadrant, and look to see what we're actually finding. We're finding the cos of something. So we've got the cos of something in the cos quadrant. which is a match. And as soon as you have a match, you know that you're going to have a positive equivalent. So it's quadrant 4, which is a match, and it's going to be a positive answer. Now let's look at the associated acute angle. If you remember in the last note, I said the associated acute angle is the angle between that line that you've drawn and the horizontal line. So what would that little angle there be? If that's 300 right round there, how much more would it be to get to that angle, that line there, the horizontal line? It would be an extra 60 because it's got to add up to 360, hasn't it? Okay, so we're dealing with 60. That means that the cos of 300 is equal to positive the cos of 60. And that's how you're going to work it out now from your exact value triangle. So cos of 60 is adjacent over hypotenuse. So you have your triangles. You always make sure you have your triangles drawn in front of you. Even if it's in an exam, you make sure you draw your triangles in the exam. Okay. And cos of 60 is adjacent over hypotenuse, which is 1 over 2. Okay, and that's how you would find the cos of 300 because it's the same as the cos of 60. Okay, if you were to look at your cos graph, and you would see then that cos of 60 and cos of 300 would be the same height on the cos graph, and they would both go up to 1/2. So these are the corresponding y values for these corresponding x values. Okay, that's what that means. Let's have a look at this one. What is the exact value of tan of 150? So let's put it into the table. So there's 90 round to there, that would be 180, so just short of 180, so just 150 is in there, in quadrant 2. So look at the quadrants again, remind yourself what quadrant 2 is. Quadrant 2 is the sine quadrant. So we're finding the tan in the sine quadrant. We're finding it in quadrant 2, the tan in the sine quadrant is not a match, so that means it's going to be a negative equivalent. Okay, so it's going to be a negative equivalent of whatever the tan of the associated acute angle is. Now looking at here, we're looking always comparing it to the horizontal line. What is the angle that you would have in here between that line and the horizontal line? That's the associated acute angle. So the associated acute angle is going to be 180 minus 150, and it's a little 30 that's in there. So we're going to find tan of 150 by doing negative tan of 30. So now we look at our table and we get the tan of 30 from the table, opposite over adjacent. So it's negative 1 over root 3. Okay, what about one that's given in radians? Don't worry if it's given in radians. What I would suggest you do is just convert it to degrees. So just do the change, 5 times 180 divided by 6. Do the 180 divided by 6, which is 30, and that's just 5 times 30, which is 150. So we're actually finding the cos of 150. I think it's easier to think of the working the table with degrees. So let's use the table now. Where would 150 be? It's going to go right round there into the second quadrant again. And what would be that extra angle that would take you to the line? It would be a 30 in there, wouldn't it? But let's look at which quadrant we're dealing with. We're dealing with the second quadrant because that's where the line is, in quadrant 2, which is the sine quadrant, and it's the cos we're finding, the cos in the sine quadrant, which is not a match, so it's negative. So we're going to be having a negative equivalent, and the associated acute angle will be 30. So it's going to be negative cos of 30. That's the equivalent one. So it's the same value as negative cos of 30. And we get the cos of 30 from the triangle, which is adjacent over hypotenuse from 30. There's your adjacent, there's your hypotenuse. So it's negative root 3 over 2. Okay. And here we have example 4. What is the exact value of cos of negative 7 pi over 6? We have two things going on here. We have radians, but we also have a negative in there. So I'll show you how you deal with that in a moment, but let's work out what 7 pi over 6 is in degrees. 180 divided by 6 is 30. 7 times 30 is 210. So we're going to be working out the cos of negative 210. Now, normally 210, we would go round that way. 90, 180, 210 would be in there somewhere, wouldn't it? But it's negative 210. all that you do with that when there's a negative in there is it means you go clockwise. You go the opposite direction. Instead of anti-clockwise, you go clockwise in that way. So there we would have 90, 180, 210 would be in there now. So it just completely changes the direction of it. You go in a clockwise direction. Okay, so 210, if that would be 180 to an extra 210, we can work out our associated acute angle as being an extra 30 in there, which we'll do in a moment. But we're now in quadrant 2, which is the sine quadrant. Cos in the sine quadrant, again, it's going to be a negative, not because that's a negative, just because the quadrant we've ended up in is not a match. So we're finding cos in the sine quadrant, which is not a match, so it's going to be a negative equivalent. Okay, and it's going to be a negative equivalent of cos of 30. So negative cos, because that's what the question has, 30 because that's what the associated acute angle is. So it's negative cos of 30, which is negative root 3 over 2. Okay, from cos of 30 adjacent over hypotenuse. And that's just actually come out of sync a little bit there. So negative cos of negative 7 pi over 6 is equivalent to negative cos of 30, which is negative root 3 over 2. Okay, here's example 5. Just excuse my bell going just now. What is the exact value of tan of 11 pi over 4? Let's work out what that is in radians. 495. Now what that means is that we go round more than one cycle. There we have right round to 360 and round again. So how much more than 360 have we gone? So we're going to work that out and see how far round we've gone. Now we're into the second quadrant, which is the tan and the sine quadrant, so it's a negative. Okay, and we had 495, so we had to do an extra 135 to get to that one there. That's why it's in that quadrant. And that's why we've got a 45 angle from there to there. From 135 to 180 is an extra 45. So it's a 45 triangle we're using this time. Okay, so it's negative tan of 45. So that just meant that we had to go around more than one cycle. We need to do then, we've gone beyond the 360. How much more than 360 have we gone? 135 extra, and another 45 would take us to our horizontal line. So negative tan of 45 is opposite over adjacent, which is negative 1 over 1, which is negative 1. Okay, so you can now do exercise 4E, the question selected, and ask your teacher if you need any help. Take care and good luck.